Here's where we got with part 1 with the Earth model checklist. And we've got, yep, it looks flat to me, comports with globe as well as flat. The sunset azimuth, the globe past that, the flat Earth failed that one. Sun elevation angle, the globe matches, flat Earth fails miserably. Now we're going to continue on. Now I know that sun height is very similar to sun elevation angle, but I just wanted to talk a little bit about the sun height in the subsequent photos, and I wanted to separate it out as a separate thing, even though really it is technically the same. Now, the other thing now, we've got to look at the moon prediction. So for that day on the 21st of September at 6 p.m. roughly, there's 28 degrees in the sky and a heading of 121 degrees, which is about 40 degrees south of east. So that's what the moon should be doing on that day. And looking out towards the east. Now before, when we observed this in the panning around 360 degrees, we saw that those hills were full sunlight, and now they're starting to come into shadow. So as the sun dips lower, the sun rays are blocked from the mountain range that is in the west, and eventually blocked by the curvature of the earth. But you can see that's starting to fade away. Very clear that there's shadow on the bottom and not shadow on the top. And I'm going to play a video now, which is pretty cool, I think so anyway. So here we go. You can see that the I'm just filming the shadow rising up. That's amazing, isn't it? It's getting darker on those hills. Now, some may argue that this could be cloud. Well, it's remotely possible, but the cloud would have to be moving at a very special rate. As the sun's going down in the west, well, in the east we were lucky enough to see these anti-crepuscular rays, and the moon is there up in the sky. Now, I don't have any way of measuring the elevation of the moon. If I had a sextant with me, maybe I could. And I can't really measure it from this photograph, but 28 degrees is approximately 1/3 of the way up the sky, because directly overhead is 90 degrees. And that looks to be approximately 1/3 up the sky. Hard to get a good measurement, but it's in the right area. Trying to measure the azimuth or angle of the moon is a little bit more difficult because there's this tree in the way there. But what I've managed to do is I've managed to identify a couple of buildings there on the map. So there's this building, which is right in front of us, and then there's another building that's a little bit further away. And you can see that the moon goes to the right of both of those buildings. And then what I've done is I've drawn a line at 121 degrees from my observation point, which is the angle that the moon is supposed to be at. And you can see I've identified these two buildings, and you can see that the line goes to the right of those buildings. Now, I've also can further just make sure that I've identified the right buildings. I can go in Street View. So we'll go out first of all. Whoops, let's go outside. Go outside the hotel. In the street, we find our bearings here. So there's the hotel and my observation point, and there's the tree that's in the way. So here's the building, the first building I've highlighted. We can have a look at it this way. So that's that building there, and then the other building, you go down this street. Not too far maybe, because it's a bit hard to see that roof. But there's a flat roof there. I don't know whether I can get here's a flat roof. You can't see the white bit on the top, but that's building. You know, it's this building. It's got a flat roof. It's on this corner. So that's how I've identified those. So there's our hotel. There's this building on this corner of this road. There and here, this first corner here, there's that building. So if we go back to the other picture, so there's my 121 degrees, and there's those two buildings. I think that's pretty good. Look at that. I think that's pretty good. That's pretty close. And here now you can see the sun is shining into those clouds there from the west. There are some shadows you can see on the back of this cloud, and these shadows are what would be causing the anti-crepuscular rays that we see heading out towards the east. And the other thing you note about these is the convergence point is somewhere just around the horizon or below the horizon. So this convergence point will rise as the sun sets more towards the west. And the sunlight on the clouds is pointing to a pattern that is lit from the side, from the west. Now I have another video to play, and we'll see what this has got. It's just a bit of a pan around on the eastern side. And you can see the anti-crepuscular rays converging into the distance. And I'll just skip through some of these, some more of the same. Really nice photos. This one here, you can easily see the shadow caused by the sun on the cloud. There's some sun underneath this bit of cloud here, and this cloud is in shadow, and there's some more shadow streaking through the sky there. And the shadows go all the way through the sky. That's a fantastic sight. And they're starting to rise up a little bit. The convergence point is rising, starting to rise. The clouds here are becoming in shadow. And that you can see sun in the direction from underneath, and you can see the sun sometimes shining underneath the cloud there. It's a bit hard to pick out in some places, That's an excellent shot of the shadow cast by the sun in the sky shining on those clouds, and some underlit clouds there. Now there's a picture I happen to notice in the sky, Venus. That's an out of focus shot. So I tried again to, you can just see the little crescent, very small in that shot. I tried again with a different exposure, and I finally did get one shot that was pretty much in focus and zoomed in. So that's the crescent of Venus there, and another fantastic picture showing the shadows streaking off to the east, and some underlit clouds on this cloud here and over this way. The convergence point is rising. It's rising. It's almost at the top of those mountains now. The other thing you'll notice is the sky is starting to darken down near the horizon, and the Earth shadow is starting to rise. The area near the horizon is becoming darker, and that's part of the Earth shadow due to the sun going down over the edge of the Earth. And in Phuket words language, that would be the ground is rising up to block out the sun. Well, of course it does, yes. And you can see that there a little bit more pronounced. So here's a shot that was from earlier, just for comparison. So there's no shadow, Earth shadow, and there is there. And that's, you can see, getting very dark down near the horizon now. Shot of the clouds, some lit from underneath. Almost gone. The whole sky is becoming very dark now. Very hard to see the anti-crepuscular rays. And some more underlit clouds. So I've taken the diagram I had before and drawn a few more lines on it, and I'll explain this a little bit. The red line is where on a flat Earth the sun is at sunset. It's an angle of 20 degrees. The blue line was the sun, very close to sunset. And people will say, oh well, the sun gets lower in the sky due to perspective. Well, yes, it does, but the angle of 20 degrees is as low as it goes in this case. And the perspective, you can see here, the angular size of the distance to the sun will get lower. That's what these pinkish lines are here. In the afternoon, in the mid-afternoon, the sun is going to be up there, higher in the sky. And then it's going to get further away. Perspective will make that angle smaller. And as it gets the furthest away there at sunset, the angle will be smaller. So the angle cannot magically go down to zero. It's 20 degrees, and supposedly we can't see the sun anymore after that. But if you could see it on your flat Earth, the angle would go a little bit lower. But this is where it is. Now, the other line I've drawn across here, the purple line, is the line that high clouds will be at. This is to scale. This is where clouds are like 6,000 to 20,000 feet, those sorts of ones. So how can a flat Earth sun, which is way up there 20 degrees in the sky, shine underneath the clouds? It can't. Again, there have been attempts to change the geometry by uttering the word perspective, but perspective is completely unable to change geometry. If something is higher than something else, perspective cannot make it lower. And this has been a lot of talk about that lately, and demonstrated by everybody. Perspective doesn't change the geometry. So the way the clouds get underlit is the sun has gone down, the earth has rotated, and the sun has gone down below the horizon, shining on these clouds, which are 6,000 to 20,000 feet. But the sun is at a negative angle now and then shining on the bottom of the clouds. So let's see how we're going with our checklist. So I've talked about sun height. Now the sun height, what I mean was, well, the height of the sun is lower than the clouds, when as shown by shining on the bottom of the clouds, and as shown by the anti-crepuscular rays. The sun can get low enough over the horizon, low enough in the sky to shine on the bottom of the clouds and to produce all those effects that we saw in those photos. And that's why I put an X beside the sun height for flat, because the sun's too high. It's too high to produce the effect of those anti-crepuscular rays, because the clouds are lower than the sun, always lower, and the shadows can't be formed like that, and the sun cannot get low enough to shine on the bottom of the clouds. So I've already discussed the anti-crepuscular rays a little bit. So they converge to a point, the anti-solar point. They're parallel rays. I'm not saying that a flat earth can't have crepuscular rays. It can, because the sun can shine through the clouds. But anti-crepuscular rays cannot, because there's no way you can get a shadow from the clouds to go across the sky like that to the anti-solar point. The sun's up there on its own with nothing to block it. So that's a fail for the flat earth. Now the moon position. It was roughly in the right area, and right about 28 degrees in the sky and east-southeast, so I'm going to give that a tick. Now for the moon, who's to know? I'm not sure that the flat earth has any model that can predict the moon position. I've seen now the latest clock is supposed to have the phases, which is okay, but I've not had a chance to check the position. So I'm going to say that that's a fail on that one, because there isn't a real model that I've seen. And I'd be happy to investigate one if there is. The Venus observation, again, I don't know really what is it that the flat earth tells about the planets. If they're still just lights on the dome, well then how come Venus is round and has a crescent shadow on the where the sunlight doesn't, like the shadow on a ball. It's shining on Venus and it's forming a crescent. So Venus is round and an object in the sky. I don't know how you can paint that on a dome and have it change like that. So I'm just going to say no to that one. And the observations fairly clearly are more favourable to globe Earth. The flat Earth, the only certainty one there, the only certain one there is, yep, looks flat to me. But there's all these other things that make zero sense on a flat Earth. And so, I don't know why people want to argue about it. Thanks for watching, everybody. We'll see you again in another video shortly.